Hello, this is going to be a video on the tape measure. It's been my experience that many people coming into the trades don't have as much experience with the tape measure or fractions as one would expect. So I'm going to try and make this process a little bit easier for you so that the tape measure techniques you'll need will be more immediate in your brain. Let's start first of all by reviewing basic concepts about numbers. If I draw a line, and that's a hole, that is one segment. If I cut that segment into two equal pieces, then it's pretty obvious. If I was starting to use this measuring tool as my device and I start off at the 0, my first tick would be half, and my second tick would be 2/2, which is the equivalent of a hole. Took that same number line and I cut it into 4 equal pieces by cutting a half into half. I would have a different measuring tool. 0 would be the beginning. I would then have 1/4 or 1/4. The second line would be 2/4. The third line would be 3/4. And the fourth line would be 4/4 or 4/4. That, of course, reduces to 1. You should be saying in your head, but, doesn't the 2/4 also reduce? If you look right above it, the 2/4 is equivalent to a half, and you're absolutely right. So in lowest terms, if you were doing the best number line possible, you would indeed reduce that to a half. I'm going to take the same number line and I'm going to cut it again. This time I'm going to cut the 4ths into further sections. So now my number line has 8 pieces. Starting at the 0, I have an 1/8, 2/8, which you're saying, but yes, you're right. That reduces again to 1/4, 3/8, 4/8, which again, yep, reduces to a half, 5/8, 6/8, 7/8, and 8/8, which is a whole. Out of those numbers, in the real world, you wouldn't ask somebody for 2/8 of an inch, 4/8 of an inch, 6/8 of an inch, or even 8/8 of an inch. All those numbers can reduce. Let's do that same number line divided up again. Our starting number line is an 1/8. Let's take each of these and divide them again. So now, my segments are smaller. I'm going to have a grand total of 16 sections. I'm going to write the unreduced numbers first, then we'll reduce them. So, and this is going to get kind of crowded. 1/16, 2/16, 3/16, 4/16, 5/16, count over, 6/16, 7/16, 8/16. You should be saying, hey, that's half, and you're right. The second half of the 16ths are going to be scrambled and messy. I'm going to try, so we're at 9/16 here, 10/16, The blue line is 11/16. The red line I even lost my own train of thought. 11/16, 12/16, 13/16. Clearly this is a bit jumbled. We need to redo this, and we're going to do it again with the reduced fractions in place where they belong, so it has more value. So I'll kind of try to direct where they belong. Okay, write the rest of those fractions and try to draw little arrows up to where they belong. The purpose of doing that, though, although it seems a little jumbled, is I want you to be able to look at the 16 pieces in a number line, and I want you to be able to generate quite quickly what numbers go in order from left to right. So I want you to be able to come up with the fact that the first mark on your tape measure, that single line, is a 16th. The second mark over, which is a little bit longer, is 2/16, but that's not realistic. Let's reduce it down to what it really is, which is an 1/8. The third mark over is 3/16. It cannot reduce. The fourth mark over, if you look at your number line, is actually 4/16, which is 1/4, or 1/4. The next one over, 5/16, it can't reduce. 6/16 is 3/8. The next one is 7/16, can't reduce. The next one is 8/16, which is your half. Then you get the second half, so the next one over is 9/16. That cannot reduce, but 10/16 reduces to 5/8. 11/16, again a prime number of 11, cannot divide into 16, but 12/16 is 3/4. And then after 12 comes 13, so 13/16 cannot reduce, but 14 is actually 7/8, 15/16, and then 16/16, which we'll just call 1. Bottom line, on a measuring tape, typically the numbers for a half and quarters are a little longer, and then the eighths are a little shorter, so you get little shorter ones for the eighths, and then you get the shortest, which are the 16ths. So in terms of how do you be successful with the measuring tape, what I've seen people do, it's not highly recommended. If they wanted to know what this measurement was on a measuring tape, they might count over 9 places. Oh, that's 9/16. But you should be able to recognize your quarter, your half, your 3/4, and then know at half in your head very quickly that's 8/16, so 1 more is 9. 9/16. You should be able to, in your head, understand how 1/4 and 3/8 compare. You should know that 1/4 is the same thing as 2/8, and therefore 2/8 is less than 3/8. Those types of things. Those are the kinds of comparisons you need to do in your head, and do them quickly. This picture that I'm showing you now is an actual photo of a tape measure. You'll notice that they actually marked the tape measure with the appropriate numbers. So the quarter, the half, the 3/4. Notice that these lengths are longer. Okay, there's your quarter, half, and 3/4. the next shortest lengths. There's your eighths. So 1/8, 3/8, 5/8, 7/8, all the ones that don't reduce. And then the shortest of the short, there's your 16ths. So you could count them down the bottom. 1, 2/16 reduces to 1/8, 3/16, and so on. 5/16 is less than 7/16, and 7/16 is less than 11/16, and 15/16 is almost 1 whole inch. It's 1/16 short of an inch. Okay, if your tape measure has those markings on it, that's great, but they don't put those markings all the way along the length of the tape measure. They do it for the first foot or so. And then if you get to a piece of pipe that's 23 feet long, you're not going to be able to go back and look at this mark on the beginning of your tape measure. You're going to have to know it. So start to get familiar with these things. Here are a few diagrams that are stolen from the internet. Number 1 on the left, multiple choice question. It's meant to represent 1 full inch. The first thing that I notice is that it's marked off into long sections. So we have, this is your half, and then you have your quarters, and so on. The red line is pointing to 4 marks over or directly on 4/16, which is a quarter. And that will be your answer for that one. So you could count over 4 spaces and reduce, or you could just simply recognize by the length of the lines that it's actually at the quarter mark. The second one's a little bit harder to do. It's not maybe as obvious. I try to get my bearings by looking for place markers, so I see that this line is the half. I see that the next long line is 3/4. A shorter line is going to be 1/8. The smallest line is a 16th. So I could do it 2 ways. I could count from the half, which is 8/16, over 2 and get 10/16, which reduces, or I could tell that the line that's shorter than the half and the quarter is 1/8 and recognize that it would be 5/8 because it's 1/8, 2/8, 3/8, 4/8, 5/8. So I'm not going to press upon you how to do it. I just want you to figure out a way that works for you. A couple more questions. This one's a true and false. The first one says it's the red mark is pointing to 13/16. Well, 13/16 is almost 16/16. It's 3 marks shy of the whole. So if I was looking at it from that approach, 3/16 should be there. In fact, it's back 2, which would make it at 11/16. Or you could do it forward and say, there's your half, 1, 2, 3 marks beyond that. So 8/16, 13/16, you could do it that way. That would be 11/16 where it's at, but so it's definitely not 13/16 where it's at 11/16. And number 2 says that it's 15/16. Well, 15/16 is damn near a hole. 1/16 of an inch from the hole, which would make it only 1 mark back. And the red mark is 3 marks back. So that is 13/16. Last little thing that I want to discuss. Pretend that this gray line is the object you're asked to measure. So you can see that it's at least 4 inches. It's not quite up to 5 inches. So it's a whole 4 inches and then a portion of the next inch. Well, of course, the next inch is divided into sections. There's 2 ways to approach it. You could look at it by counting from the 4 inch mark over. There's a half, there's 3/4, and so on. Or you could look backwards and say, hey, that gray line is only 1/16 shy of the 5-inch mark, so it must be at 15/16, and that's of an inch, and that can't reduce. That must be the measurement 4 inches and 15/16 of another inch, almost 5 inches. Okay, just to sum up, this is a diagram that I took out of a training trades booklet published by the federal government. And if it's not obvious, and I haven't said it, I don't believe, but all the work that we've been doing with inches is what we call imperial measurement. Many of you have learned in school how to use the metric system. So tape measures, of course, will have both. And although Canada is metric, many of the trades applications are still using inches, so therefore you're going to have to know how to use those measurements as well. I think we just did a pretty good job talking about the 16th of an inch. This diagram here on the upper left actually takes the 16ths and cuts them in half again. So it shows you basically a 32nd of an inch. That's very precise. On the right hand side we have the metric system, where each centimeter is subdivided into 10 segments, so each centimeter is going to be made up of 10 millimeters, and those 10 millimeters, as you probably remember from high school, can be written as 1/10 of a centimeter or in millimeters. So for example, if your measurement of your line went up to there, that would be a grand total of almost 2 centimeters. 1.8 centimeters would be there. Or you could say 18 millimeters. Same measurement, different representation. We will do more work with millimeters and centimeters, but not for quite a little while into the course, so I thought I would mention it now. I'm sure your instructors will do a great job at teaching you how to do tape measure stuff. I just wanted the opportunity to remind you that fractions are common, and you're going to see them every day, and a little bit about how the 16ths reduced. So just for the hell of it, if you look at this particular arrow, that arrow is pointing to a measurement from a tape measure. You will see that it's pointing quite distinctly at one of the main marks on the tape measure, and that's should scream it at the 1/4 inch, and that's 3 1/4 inches. Okay, this next one over is clearly at a half, so 4 1/2 of an inch, and then the next one is actually hard to tell because I can't zoom in, but what I can tell is that it's less than a 1/4, more than an 1/8. Likely it's going to be between, I think this is actually given to you in 30 seconds or 64ths even. I'm guessing it's at 3/16, but that's a crapshoot. You can argue with me on that later. I bet you it could even be more precise, but wouldn't really be able to tell. 6 3/16 of an inch. On the bottom you have your metric system. So the first line at 3 centimeters. The second line is quite close to 4.5, I would say. 4.5 centimeters or 45 millimeters. The next one's beyond 9, less than 10 centimeters. I would say it's at 9.7 centimeters or 97 millimeters. Metric system is a lot easier to use. However, there's a lot of products in the world that do not use metric. This is why we work with imperial as well. This is 14.4 centimeters or 144 millimeters. So I hope when you go to sleep tonight, you see 1/16 and 1/8 and 3/16 and a quarter and 5/16, 3/8, etc. in your head. And when somebody asks you, is 3/8 bigger or smaller than 5/16, you could say, oh, 3/8 is actually 6/16, so it's bigger than 5/16. All those kinds of things. When we start working with adding and subtracting fractions, you'll be able to make common denominators out of 16ths. That's where this is going. So get out your tape measure, start to measure, look at it, figure out how it works, and don't be afraid. Math isn't scary. Math is fun. See you in class.